Hey, welcome to College Algebra Day 1 for 1.1 Intro to Graphing. I want to just be clear on what we're talking about when we're talking about graphing. There's all kinds of graphs out there. We refer to them as like pie or circle graphs, bar charts, lines, histograms, all of those. Those are legitimate graphs, but the graph that we're going to be talking about is the XY plane. Sometimes it's called the coordinate plane or the Cartesian plane. These graphs have some universal characteristics, and I'm going to run through some of those. It's some of the vocabulary. Most of this you probably already know, but I just want to make certain that we're all on the same page, and I'm trying to make certain that we're going from things that we do know to things that maybe we aren't as solid on. So, horizontal axis, we frequently refer to it as the x-axis. This has to do with the independent variable, and we'll talk at some point more about what that means. And it can also be thought of as the real number line, right? This is the one where we draw, it's a horizontal line, and we always think about, okay, here's our number line, 0, 1, 2, 3, 4, and all that. So the vertical axis is generally called the y-axis. Sometimes it is referred to as f of x, all right? This is, and we'll talk more about this later on, but I want to at least touch on it now. F of x, or the function that depends upon x, is not multiplication of x times f in this x. This is a notation that basically tells you this is the y value at such and such a point. So when that x is a number, we're saying, okay, that number is the x value, and here's what the result is for the y value. Okay, this is the dependent variable. It is told what to do by the x, and this line can be thought of as the imaginary numbers line. Again, we haven't really talked much about complex numbers, but we will be talking about them. So I want to make certain that we at least are aware that imaginary numbers exist, and we won't worry too much about them until we've had a chance to talk about complex numbers. We have the origin. That is the point where the horizontal and the vertical axis intersect. The point is labeled 0, 0. It can never be anything else. On the horizontal or the x-axis, all points to the right of the origin are positive, and all those to the left of the origin are negative. So on the vertical or the y-axis, all values above the origin are positive, and all of those below are negative. So, and we'll have a visual of that here in just a moment. I want to make sure that we kind of cover the vocabulary first. So we have quadrants, and there's 4 portions that are created by that intersection of those two axes. Quad always means 4. We denote these quadrants using capital Roman numerals. We begin in the upper right, and we're going to go counterclockwise. If you hear it referred to as anti-clockwise, that's somebody who's probably from Europe somewhere, because that's a preferred way of saying anti-clockwise, or counterclockwise there. All right, so the coordinate point, this is our ordered pair. This is knowing where we're going on the graph. We take the format of x, y. X is bossy. It always comes first. And like I said, it's bossy. It tells y what to do. So I would make certain that you are really solid that x and y, it's x, y, and which one is which. Okay, so the x value is occasionally referred to as the abscissa, and the y value is occasionally referred to as the ordinate. I will not be chasing those down on you. I don't use those terms practically ever. I just want to make certain that you've at least seen the words. All right, so for plotting, this is where we're going to graph something. We put it on the XY plane. So here is the whole thing that we've just talked about. Here's my coordinate 1. Or my quadrant 1. Here's my quadrant 2, 3, and 4. And here you see your origin, that's 0, 0. Everything to the right of that is going to be a x that's positive. Everything to the left of that, I have my x as a negative. Everything above the origin is going to be a positive y, and everything below the origin is going to be a negative y. All right, so that's, like I said, that's pretty much the summation visually of what we just covered. All right, so there we go. When we're asked to solve a solution for an equation, right, we have two variables that some have solutions. We want to use the form, if we're given a value and we're asked whether it's a solution, we use that value to plug into the equation ax plus by equals c. If it is a true statement, then it is a solution to the pair. And I did not erase this, but I wanted to go through and just show, here's my 2x plus 3y equals 18, and we're asked to use the point 5, 7, right? So I'm going to replace the variable with the value. So my x variable is going to become the value of 5, and that's shown here. So my 2 times 5, and then I have a 3 times my y value, which is 7, so 3 times 7, and is that going to equal 18? It becomes pretty clear very quickly that this is going to be 31, and that is definitely not 18. You can't have them be the same number, so it's not a solution. In this next case, we have the point for the same equation. I have the point 3, 4. So again, I'm going to replace my variable with the value. Here I have the 2 times the 3 for my x value, and the 3 times the 4 being for my y value, and we're asking if that's equal to 18. Well, 6 plus 12 definitely adds up to 18, so this has a solution that is 3, 4. Okay? Couple things about intercepts, and I realize I'm kind of zipping through this. I want to see what I can get covered without having to make multiple videos if I can. All right, so the intercept is a point that crosses, where the function crosses one or both of the axes. Okay, so axes is the plural of axis, and so you're going to have, in all but 3 cases, you're going to have 2 answers. All right, and I'll go through what those 3 are with you right now. So if I go through the origin, right, if I have a line that passes through the origin, my x-intercept and my y-intercept are the same. It's that origin. All right. If we have a horizontal line that is not the x-axis, right, there is not going to be any y-axis, right? There's only a y-axis. There's never going to be an x-axis or an x-intercept, because you are only going to cross at y. Now, if you land on the exact 0 for y, where you've got the whole, whatever your answer is also the x-axis, there's an infinite number of points. We're not going to worry too much about that, but I want to make certain that we know here, if it's a horizontal line, we're only going to have a y-intercept, and if it's a vertical line, we're only going to have an x-intercept. Those are the only 3 cases where you do not have 2 solutions, so be aware of that. When we have an x-intercept, it's written as whatever our value is, comma 0, and the y-intercept is written as 0, comma, and then our value for the y. All right, again, I'm going to keep with the same function that I've been using. I want to make sure I get this all sorted. So we're going to try for the x-intercept, and we're going to do that by placing a 0 in our y, which probably feels counterintuitive. It probably is like, why are we doing something with the y when we're trying to find the x? Well, if you're finding the x-intercept, right? Let me scroll up here. If I'm finding an x-intercept, it's something on the line. It crosses here, right? If you are on the x-intercept, your value is, your y value, it's neither positive or negative, it's 0. It's sitting right on this, this line, which the y value has to be 0. So that's actually what we do. And here again, it's going to be the same kind of concept for our y-intercept. We're going to be right on the axis, so we can't, our x value can't be anything other than 0. So going ahead and looking at that or thinking about that, we're going to go ahead and plug it in. So I have 2x plus 3 times 0, right? We're told to put that in for the y. And we're asked if it's 18, we go ahead and solve it. Our x is going to equal 9 in this case. So we have the value of 9, 0. That is the point that we're asked about. I want to be absolutely clear that you do not try to smush these two together. The x-intercept and the y-intercept are almost always two different values. You're not smushing them together, so it's not going to become something like this. All right? That's a completely different point. Here, I'm going to find my y-intercept with the same general concept. My x has to be 0, so I plug in a 0 for the x. I have a 3y left. 3y equals to 18 is going to get me a 6 when I'm done solving for that variable. So I wind up with 0, 6 as my answer. Okay, again, this is not, we're not smushing them together. You can't use this. It's two different points. So 9, 0, and then 0, 6. All right, so I'm going to just show the work that we've kind of already done here. You can see there's our 3 points. All right, and we wind up with our ordered pair, right? Remember, this is actually looking for some points on the graph. So I'm going to scroll this up just a little bit. And here you can see all of our values and where our points are. So for our y-intercept, we had x equals to 0, right? X was equal to 0. So that meant here my value was 6, or I can say y-intercept here. And as long as I've labeled it somehow, I could say 0, 6, or I can say, have the graph numbered to be 6. Either one of those is fine. I just need to see that you are doing the work so that so that I know you know the material. All right, so that's one of the points. Here's my next point. I have a 0 and a 9, right? My 9 is my x value. My y value is a 0. So when I go ahead and I plot that out, there's my 9, right? And it's where it crosses, so my x-intercept is going to be at 9, 0. All right? Because I don't go up or down. I'm exactly on the axis. And then we had our third point here. We have this 3, 4. So halfway to 6 is a 3. And if you go across, and then you have a 3, 4, and then if you were to drop that line to the 4, you're going to have something that's really close to halfway, but a little less than halfway to the 9. Okay? Hopefully that's all making sense, and I left all this information up so that we can kind of get used to thinking about it like that. All right, so here I'm given another line to work with. And this is a case where, and here actually I think I'm going to just go ahead and erase this, and then I'm going to stop this video and I'll come back on the next one at this point.